Alrighty, friends, let's go ahead and bust through this review so that you feel more confident and can ace my test before spring break. Okay, so this is a lot of numbers. Let's see, how many numbers do we have here? I think I counted them up, and n is 15. I think on the test it's like 5 or 6. There's no way you have to do this many numbers on the actual test. So finding the mean, which is the x bar, you're going to add them all up and divide by how many there are. So in this case, you're going to divide by that 15. I'm not going to take the time to go through that because you guys know how to add on your calculator, get that answer, divide by 15, and you should get 80. Now it's super easy to make a mistake because there are so many numbers, but again, the test won't have that many. The median requires them to be in order first, and so that's kind of a hassle. But then once you do that, you find the middle, and the median of this one is 81. If you have two numbers in the middle, like once you put them in order and kind of chop your way into the center, if you have two numbers in the middle, you would find their average. So we have an odd number of numbers, and so that's not a problem. But if we ended up with two numbers in the middle, you would take that first number plus the second number and divide it in half if you had to. Mode is the most reoccurring number, and in this case, both 76 and 82 are in that list. You can see there's 1, 2, 3 82s and 1, 2, 3 76s. And so they're both modes because they're tied. Range is going to be your highest value minus your lowest value. And so in this case, we end up with a 12 when you do go through there and find the highest and the lowest. I believe the highest is 85, glancing through here quickly, and it looks like the lowest is 73. So for us, this is 85 minus 73. Now, standard deviation, you're going to have a chart. And again, this was a total grind. My answer is 3.52. I'm not going to go through every single step with all of those numbers, but let's look at the chart that you're going to be using. When you go to do this, write down how many numbers you have, which is 15 in our case. Find the mean, which we already found, so that was 80. So this is going to be a list of all the numbers that we were given. Now, of course, this one has a bazillion, 15 numbers. We're just going to have 6-ish, I think. Here, I'm just finding the difference. So in my numbers, some of them, I'll put a couple in here to start with. Some of my numbers were 84, 73, 76, 80. So I'd list all of them normally, but I'm just doing a for instance. Here I'm finding the difference between the numbers from this list, see how they're both X's, and the mean. So I'm figuring out how far they each are from 80. You figure out how far apart they are by subtraction. 84 minus 80 is 4. I don't write negative numbers. 73 minus 80 is negative 7, but I just write 7 because I'm going to square it. The negative will go away. And all it's saying is that 73 is 7 below the average of 80. So I don't even put that negative because it just ends up confusing me. 76 is 4 away from 80. 80 is 0 away from 80, and so on. So you would do that for all 15 numbers. Okay, so number 1, find the mean. Number 2, figure out how far each number is away from the mean. Now, if you look, it's just doing one step at a time. Here we had x minus x bar. Now we're doing x minus x bar squared. So I'm squaring each of these numbers. 4 squared, 16. 7 squared, 49. 4 squared, 16. 0 squared, 0. And I just keep going down the list. So first I found the mean. Second, I found the difference. Third, I squared those differences. They should all be positive numbers. And then here it says to find the sum of this, which is what we just found up here. So I'm just adding these up. So I add these all together, and then that becomes the number that goes right here. And then if you look, this top part of the next step is that same thing, x minus x bar squared, divided by the number of numbers there were, which was 15. So I would be taking this previous total from right here, dividing it by however many numbers there are. That's going to most likely give me some kind of a decimal. And then this whole thing is identical to that. because I'm just taking the square root of that decimal. And what I get will be my standard deviation. So this number that you get right in this spot, that's going to be my standard deviation. When I did all those steps, I got 3.52-ish. So there will be a chart that walks you through it. It'll be the one that was like this, where it has the steps at the top. And so that'll hopefully help you through that process. So it's time consuming, but it won't be as bad as this one because you simply won't have that many numbers. Okay, so now suppose that all the basketball players are wearing 4-inch heels. That is adding 4 to each data set. So if you look back at your notes or you remember, that only is going to add 4 to the mean, median, and mode. Adding and subtracting does not change the standard deviation or the range. It only changes the measures of center. So I'm going to take my old mean and add 4. So I'm just looking from up above. My old median was 81. I need to add 4. I had 2 modes. I still have 2 modes. I take my old 76, add 4, get 80. Take my old 82, add 4, and get 86. These two won't change because it's not more spread out. It just all scooted up 4. So this stays 12 and this stays 3.52. So that's adding and subtracting a value to the data set, only changes the 3 M's. Now, here, new set of data. We don't have to find the mean, median, and mode. Oh, I guess we do. On the test, you only have to do it one time. So when I add these up and divide by how many there are, I get 80, excuse me, I got to scoot down farther. When I add these all up and divide by how many there are, which is 1, 2, 3, 4, 5, 6, 7, 8, then I end up with a mean of 15.56-ish. My median is the 15.24. Because that one has to be an average. Since there's 8 numbers, I do end up, once I have them in order, I do have 2 that are in the middle and I have to find the average of those 2. The mode that occurs the most is the 1499. Sometimes you don't have any that repeat, you don't have a mode, but in this case, the 1499 is listed twice, so that makes it the mode because none of the others are listed twice. The range is going to be the highest priced one, which is going to be this guy, it looks like, minus the lowest price, which is that guy. And so they're $6 apart. And then my standard deviation, I go through the same process as we did with the chart before, and I end up with 1.75. And again, you only have to do it one time on the test with about 6-ish numbers. Now, suppose you have a coupon for 18% off, so it's a discount. If it's 18% off, you would say, okay, well, 100 minus 18 means that I'm going to be paying 82%. So if it's 10% off, you're paying 90. If it's 20% off, you're paying 80. If it's 18% off, like in this example, you're paying 82%, which means you're going to multiply your values by 8.2. That's how you find 82% of something. So if I am multiplying by a number, that changes all 5. That's the deal. If you're multiplying or dividing, all 5 change. If you're adding or subtracting, just the M's. So I'm going to take my old values and multiply them by 0.82. And so my new set of data is going to be 12.76-ish. My old median multiplied by 0.82, because all of them are going to be, is about 12.49-ish. Here, if I take my old mode of 1499, I get 12.29. 6 times 0.82, because all of them are getting multiplied. All of them do with its multiplication. That's going to come down to 4.92. And my old standard deviation is going to be multiplied by 0.82, and the new standard deviation will be 1.43-ish. Okay, so we have some monkeys here, normally distributed. We're supposed to be drawing a normal curve, so it looks something like that. The mean is in the middle, and then I need 1, 2, 3 lines, 1, 2, 3 lines. This is 1 standard deviation, 2, and 3. This is right smack dab in the middle. -1, -2, and -3. So this is where that pink card is going to start coming in handy. It says that the mean is 17, so I label the middle with a 17. Then it tells me the standard deviation is 3. So going this way, I'll add 3. Going this way, I'll subtract 3 every bar. So here, +3, +3, +3, -3, -3, and -3. Okay. So now one of two things is going to happen. The numbers they give me are going to be these numbers that I just wrote, and then I can just do the chunks and add the percents, or it's going to be a number that's not one of those, and I'll have to do a z-score, but it will tell me as I go. So here, find the probability. So that's going to mean a decimal, not a percent. A randomly selected adult weighs under 14 pounds. So to me, here's 14, that's on the bar, so I can just use the chunks, and under means less than, so it's this chunk, this one, and then that little sliver up to the left of that. So I look on my pink card, this one's 0.15, this is 2.35, and this one's 13.5. So when I add those three pieces that are all to the left or less than the number they gave me, I add them up, I get 16%, but as a probability, that's going to be 0.16, sorry. And all I'm doing is I'm taking the decimal here and scooting it over 2 to the left. So 0.16 is my probability. This is saying what percent, so I'll be able to give my answer as the percent, weigh between 11 and 20. Okay, where's that? Between 11 and 20 is going to be from here to here. So again, they're both on the chart. So I'm just going to be adding this piece, and this piece. We already know that this piece here is 13.5. And then these two are 34, which you don't have to memorize. It's on your pink card. And so when I add those three chunks that are in between, I get 81.5%. This one's asking for percent, so that's my answer. If it asked for the probability, I would go 0.815. It asked for probability up here. It asked for percent here. So kind of pay attention to that. Okay, so here we have a mean of 16 and a standard deviation of 4. And this is where it starts talking about z-scores. So now we're going to be using that table on the pink card. So keeping in mind that to find a z-score, you take the value they gave you minus the mean, which for us is 16 because they told us, over 4, which is the standard deviation because they told us. So here it just says to find the z-score for 22. So 22 minus 16 over 4. And I need to get a number between 0 and 3. So 22 minus 16 and then divided by 4 is going to give me 1.5. That is the z-score. That's all it's asking for. I'm done. Keeping in mind that when I go to do this on here, 1.5 is halfway between my 1 and 2 line. And so I'm talking about right about here, 1.5. Now, what is the probability? Probability indicates that you need to give a table number as your answer. Less than 32. On my pink card, it says probability of X less than, then it says to use the table number. That's really messy even for me. And so that's what I'm going to do. I'm going to go ahead because the table number does give me from here on down. So I look up 1.5 on the chart and it gives me the table value of 0.9332. And I use the table value because it says to use the table value. What is the probability that a randomly selected person has an annual consumption greater than? It's still 22, so I'm still using the same z-score. We're still at the same spot. But greater than, if I look at my pink chart, if it's greater than, it says to do 1 minus the table number. So the table number is the same as it was in the previous problem. It's just that now I'm looking to the part to the right, so I do 1 minus that same value, and I end up with a very small sliver of a probability, but that makes sense because you're over here, which is a really small slice of that. And then it's saying, what's the probability that it's between? Well, in between on my chart, it says if it's between, I need to take the big table number minus the small table number. Well, I already did everything I need to do for 22. I already know that the table number for that is 0.9932. I have to do the 13. I don't even have a z-score for that. So 13 minus the mean that they gave me over the standard deviation that they gave me is going to put me at a z-score of negative 0.8. That's a z-score. Then I look it up on my table, negative 0.8, and when I look that number up, I get 0.2119. So these are my two numbers. So for between, I'm supposed to take the bigger number, which is the 0.9332, subtract the smaller one, which is the 2119, and the difference between them is my answer. So probability is always chart values. Either you're looking for less than and you use the number as it appears in the table, you're looking for greater than and you do 1 minus, or you're looking for between and you take the bigger table number minus the smaller table number. But whenever it's asking for probability, you are using the table to come up with your answers. Okay. So this is telling me there was a survey of 2,100 high school kids, so that's my N, that's my sample size, and 62% preferred gym class to have last hour of the day, so that you're not sweaty and gross first hour. Margin of error. Okay, well, keep in mind, our margin of error formula is plus or minus 1 over the square root of the number of people surveyed. And so in this case, that would be plus or minus 1 over the square root of 2,100. And that gives me a decimal of 0.0218. Oops. But I'm supposed to give it as a percent. And so then I would scoot it over 2 to the right. 2.18% is my margin of error. So whatever result I get, it could be 2.1% higher than that or lower than that if I were to survey everybody. So that's what this interval is all about. The interval that would contain the number of students, meaning if you asked everyone, not just a sample. So what you do is you take the percent that you got in your survey, which was 62%, you add the margin of error to the right, and you subtract it to the left. And then the interval is going to be from that low to that high. Because even though your survey's result was 62%, 62 minus 2.18, that's my buffer, my margin of error. The lowest it would be if you asked everyone would be 59.82 to 62% plus 2.18. So the upper end of my interval would be 64.18. So you would say the interval is from 59.82 to 64.18, meaning this is what I got when I surveyed some of the kids, but if I had asked everybody, my answer is going to come in somewhere between 59 and 64-ish, because that was my margin of error, my buffer zone around my results. Then here, you're going to try to figure out how many hours a week people watch sports. So it's just asking you to describe ways that you can tell, like you can get the information, and then it says tell whether they're biased or not. Well, no matter what way you come up with to demonstrate each way, convenience is always biased because you're always just doing what's easy or convenient. So like there's a ton of answers, but the answer you want to give is something that would be easy for you. But so like maybe you just text your friends and you're just going to ask them. Self-selected is always biased because that's the one where people volunteer. And so here you could send out like a survey if you wanted to. There's like a whole bunch of ways you could do this, but you could just do like an email survey, something that people would have to respond to. But they don't have to respond, and so they choose to, and they probably will only respond if they care, so that's giving you bias. Random is unbiased, but it's really hard to be totally random. Like, how are you going to totally randomly find out how many hours people watch? And so you would need some kind of a random name generator. something that would be, everyone's equally likely to be chosen to be surveyed. Systematic is the one that has to have some kind of a rule. And the rule might be that, you survey every 10th person alphabetically. So it doesn't matter what the rule is, it's just a rule. You won't have to come up with them on the test, but if you're given examples, you'll have to decide if it's convenience, self-selected, random, or systematic. Okay, here I'm finding sample size, so I'm looking for n, and I'm given the margin of error. And I did give you a formula for that, which was that you would do 1 over the margin of error squared, but this has to be a decimal, not a percent. So in this case, 4% would turn into, if I scooted this over, 0.04. So my number of people is going to be 1 over 0.04 squared. And 1 over 0.04 squared turns out to be 625. So they must have asked 625 people to get a 4% margin of error. All right, hopefully that helps you. Make the world's best note card. You'll have your pink card, you'll have your calculator, you'll have the sheet that leads you through standard deviation. You'll probably ace it. Have a good day. Bye, guys.